And my second score would be the x2 score, which would be 125 plus 1.04 times 8, which was my standard deviation, which gives me a score of 133.32. And again, you would write a sentence that says, scores of 116.68 to 133.32 would place a teacher in the middle 70th percentile. Okay, so in the brown, I've been told that it's 7-1.
Yeah.
71. And how about in the orange? What was it?
28.
28? Okay. So if you use, here's the thing that you have to understand. If you use your calculator, you're going to get a certain decimal, right? If you look in your table, you might be getting something a little bit different because your tables are not as accurate as your calculators. The AP readers know that you may get one or the other. I'm pretty sure that when this was done, I got it from the table, so that's why mine's a little bit off compared to yours. No big deal. I take that in consideration. In 2008 Wimbledon tennis tournament, Nadal averaged 150 miles per hour on his first serves. Let's assume that it's normal. Again, all of our statistics is dealing with normal distributions. And has a mean of 115, but a standard deviation of 6. What proportion, remember that means the same as area, probability, percentages, of his first serves would you expect to exceed 120? What's the first thing I probably should do? Draw a picture. Then find a Z. Okay, so I'm going to draw a picture first. If I draw my picture, looks something like the following. Since they're giving me information about the actual scores, I can put the actual scores if I want to. So there's 115, and they want to know about 120, and they said exceed, which means when I'm talking about exceeding, I mean I want more than 120. So I'm looking for that area over there. Bless you. When I find this information, I need to know what's going on with my probability. This is the actual question, that my actual score is going to exceed 120. That's my goal. That's what I'm looking for. So I need to find my Z. So I look for my Z score for that value, and I take 120, which is the actual score, minus my mean, which is 115, divide that by 6, which is my standard deviation, and I get a Z score of 0.83 repeating. So in order to find out my answer, I would go normal CDF, 0.83, and you can go maybe a couple more 3s if you want to, comma 999, and you end up with a number that says 0.2033 roughly. And we might differ again because of looking in the table, calculate how many decimals you went out with your Z-score. And so this is the proportion, because you want to make sure that you're answering with what they're asking, of that value that is being shaded over here and is the answer to the question that they posed. You could answer in a statement, of course. The proportion of first serves that exceed 120 miles per hour is 0.2033. In my own mind, I'm a legend. In this particular picture, we're talking about Nadal's serves between 100 and 110. So we notice that both these scores are below the mean. You can draw our picture. I always like to put the mean on no matter where it is. So here's 115. I draw my normal curve. And the scores of 100 and 110 are over here. So here's 100 and here's 110. I'm talking about the sliver that's in between the 100 and 110. So I'm talking about that amount right there. And the question that they're posing is, what's the proportion of these scores that are more than 100 but less than 110? So the only difference really is that you need to find two different Z-scores. So my first Z-score is the 100 minus 115 all over 6. And I get a Z-score of negative 2.5. Does that sound right?
Yeah.
Yep.
Negative 2.5. And a second Z-score of negative 0.83 repeating. Which means that if I'm trying to find my answer, I will go normal, CDF, and then I'll write down those two numbers, negative 2.5 with a comma in between, negative 0.83. Don't know how many decimal places you're going to be going out. And my decimal will be the proportion that I get in between, and I get roughly 0.1971. Was that the question that they asked? No, they asked for the percentage. So make sure you write it as a percentage, 19.71%. Answer the question. Proportion is in decimal format, percent is not. And then you write the sentence, 19.71% of Nadal's first serves are between 100 and 110 miles per hour. Write out the sentence. Our last question on this problem is a little bit different. They talk about the third quartile. So the third quartile is referring to a picture that looks kind of like the following. Here's our mean. And they're talking about when you go to the third quartile, 75% of your data, so X bar is at 50. So 75% would be somewhere over here. And they are talking about all of this stuff right in here. And we know that that's 75% if I'm in the third quartile. So to figure that out, I would do inverse normal, because I'm looking for the z-score this time of that 75% of my data. Remember, this is giving my z-score of 0.75. That z-score that I find is 0.67. This is my z. And then in order to find my answer, what I'm going to do is I'm going to take my mean, which was 115, and I'm going to be above by 0.67 because it's positive 0.67, so I take 0.67 times my standard deviation, which was 6, and I get a value of 119.02. And you would say that if Nadal had a speed on his first serve of 119.02 miles per hour, he would be in the third quartile. Okay, in our last slide here, in the procedure on how to find a normal probability plot, this thing is going to help us understand if it can be represented by a normal distribution, which was what Grayson was asking about. Is this stuff normal or not normal? And so this is going to tell us, is our data normal or not? And so what you're going to find out is if your points on this plot look like a straight line, then you're good to go. So the biggest thing I want you to understand out of all this information is you want to see a straight line. If you don't see a straight line, bad news. Then the answer is no. Okay? Down below here, they give us the instructions on what to do. And basically, I'm just going to run through on how to do this. I'll do one for you, and then I want you to try the other one. First thing that you do is you go into your stat plots. So on my calculator, okay, that's cool. Really? So second y equals, oh, sorry, first of all, before you do anything, of course, you enter all of your stuff into a list. So I put this first example in list 1. I entered it in. Then you go second y equals, hit enter twice to turn on your first plot. The probability plot is the very last picture. So the sixth one. So I arrow down, and I arrow to the very last type of graph, and I hit enter. Now what I want to have happen from these is I want to be in list 1, because that's where all my data is. I want my data axis to be the x-axis. I like the plus symbols. And then I go zoom stat, which I think is 9. and I look at my data. Whoops, I have more than one plot on. So the top part is a box plot from a different class. But you can see all my little X's here. Does it look like a straight line? Yes. So if I draw a graph of this stuff here, I can go draw my probability plot on the notes here. So let me go down below in my first example, and here's what I would see. I see a graph that looks like this. And then I see these dots. Looks something like this. And from up above, it says, I want a straight line. No, that's all it says, so that's good enough. All right, so I go down below. So the question is this approximately normal? So I would say yes. It seems like our data forms a line. And there seems to be the same number of data points above the x-axis as below. So yes, the data forms a line. There seems to be the same number of data points above the x-axis as below. Okay, in the second example, in my data, if you look at my calculator, when I went to stats, I put all of my data in list number 2. So you don't have to put it in list number 1, but you just have to be careful about when you do your stat plots. So when I go into my stat plots, I'm going to shut off my second one first of all, so that I don't have that showing up again. And then I'm going to go back into my stat plots. And here's what I do since I have all my data in list number 2. I would indicate that I want to be in list number 2 by going second, 2. And down below here on the screen at the very bottom, you can see that my graph looks kind of logarithmic actually. It's not linear. So if I was talking about whether or not this stuff seems approximately normal, the first thing that I would say after drawing the plot off to the side here, so here's my plot, and looking at my data, it looks something like this. And I would say, no, the data does not form a line and it also appears skewed what do you think? Skewed? Right. Has a long tail to the right. So it looks like it'll be skewed to the right.